All right, so in this segment, I'm just going to demonstrate some more Maclaurin series, like how do you convert the cosine function and like the exponential function, ln1 plus x function into a polynomial series. So when you want to convert into, let's say, cos x into polynomial series, you got to first find out f of 0, f dash 0, f triple dash 0, f triple dash 0, f fourth derivative 0, maybe a fifth derivative also 0. So you first find out the first derivative, negative sine x. Second derivative, the derivative of negative sine x is negative cos x. And then again derivative negative cos x is sine x. So you keep going that way until you come to the sixth derivative I have reached till. You evaluate them by plugging x as 0 in all of these. So you get 0, negative 1, 0, positive 1, 0, or negative 1. So these are the derivatives that I have. So once you got these derivatives, I'm going to use them to estimate the series. And I hope that the formula that we use is very clear, that f of x is actually f of 0 plus x times f dash 0 plus x squared over 2 factorial times f triple dash 0 plus x cubed by 3 factorial f fourth derivative 0 and x raised to 5 over x raised to 4 over 4 factorial. uh, uh, the This is the first derivative, second derivative here, third derivative is here, and fourth derivative is here actually. X raised to 4 fourth derivative times this, x raised to 5 over 5 factorial, and fifth derivative. So you're gonna just plug these values, just like f of 0 is 1, so that's here 1. Then negative x squared over 2 factorial, positive, this becomes 0, this becomes 0, x raised to 4 factorial times the fourth derivative. So fourth derivative you can see is 1 here, so that is put out here. Then fifth derivative is 0. So what we get is a series that is actually following certain trend. So it starts with 1 minus x squared over 2 factorial, x raised to 4 over 4 factorial, minus x raised to 6 over 6 factorial, and so on. So this is the Maclaurin series for cosine. Now let's do the Maclaurin series for exponential function. So when you do Maclaurin series for exponential function here, I can just demonstrate quickly. Now, when you're doing Maclaurin series for e raised to x, my first derivative, so f of 0 is e to the power 0, that's 1. F dash x is f dash x, f double dash x, f triple dash x. All you know that it is equals to e raised to x. So now when you find out these values at 0, all of these values, actually they are e to the power 0, which is 1. So when you generalize the formula, now f of 0 plus, so f of 0 x times f dash 0 plus x squared over 2 factorial f double dash 0 and so on. What you get is f0 is actually f0 is 1 plus x, f dash 0 is 1 plus x squared over 2 factorial plus and so on. So this is how you write an exponential series Maclaurin for um, e raised to x. Now let's just quickly go through the ln 1 plus x as well. So here ln 1 plus x, I'm going to just first find out f of 0. So f of 0 is ln of 1, which is 0 itself. Now that's first part, and then I go ahead with f dash x, which is the derivative of ln 1 plus x. So that's 1 over 1 plus x. And if I plug in x as 0 here, I get f dash 0, which is 1. Now f double dash x is if I take 1 plus x to the power negative 1. So this is, I'm going to differentiate this. There'll be negative 1, 1 plus x to the power negative 2 times the derivative of 1 plus x, which is 1. So that if I plug in the value for 0, I get negative 1, because if I plug here, I get negative 1. Similarly, you evaluate the other derivatives using the power rule and then put in the formula. So the formula is f0, which is 0, that's fine. Then x times f dash 1, f dash 0, which is 1, x squared over 2 factorial times f double dash 0, which is negative 1, x cubed over 3 factorial times f triple dash, which is 2, x raised to 4 factorial times this become minus 6 and so on. So when you simplify that, at the end, what we get is the function as x minus x squared over 2 plus x cubed over 3 and so on. So that's how you write on the Maclaurin series for sine, cosine, and exponential and logarithmic function. In the next fragment, we are covering up the key concepts of um, the composite Maclaurin series.